Hello, hello. I'm audible to you. Hello, please drop message in chat box. Okay, let us wait for 2 minutes. So, so how was the previous class? Hello, hello, Saurabh. How was the previous class? Saurabh. Okay. Good. Good evening, Megha. Good, Deepak. So आपने सॉल्व किया सारा प्रॉब्लम? Okay, so I'm going to present this. Okay, so today we are going to learn a relation. So we learn what is called set, and we know that suppose we have a set like A is the set, right? So A equal to 1, 2, and 3. So these are the three elements of the set A. Okay, good, Aditya. So let us focus here, and I'll ask some. If you have any doubt, I'll ask in the last. Okay. So here A equal to a 1, 2, 3, and B equal to 1, 2, and 4. Okay, so here if you can see that this is what, this is a set A and this is set B. Now we are going to learn a relation. We are going to learn a relation. So suppose here A equal to 1 to 3, so these are the subset of it. See, you can see. So if I'll say that 1 and 1, 1, so what is this? Oh, sorry, I can't repeat in the here. So like 1 and 2, it is the subset of, it is a subset of A, and it is also subset of B, right? So here 2, 4, these are the subset of B. So in the relation we are going to learn, we have two set A and B. Okay, like here we have to define ordered pair. So we are going to define first ordered pair. Suppose we have, let me write down ordered pair. So in ordered pair what we do, suppose we have a set A. Okay, so A is a set. So here we consider A is non-empty. Okay, and there are two elements A and B are belong to A. Then we write AB. We say that ordered pair of AB, and this A is say first coordinate. This A is say first coordinate, and the B, this B is say second coordinate. Second coordinate. Suppose A equal to 1, 2, 3. 1, 2, 3. Now here we have 1, 2. So 1 is the first coordinate and 2 is the second coordinate, and this entire is ordered pair 1, 2. Now we can also write 2, 3. So this is the first coordinate, this is the second coordinate, and we have the ordered pair 2, 3 as ordered pair. Fine. After that we are going to learn Cartesian product. So Cartesian product. So in Cartesian product, what we do? So Cartesian product of two sets. Okay. Suppose you have element A, okay, and B. So we write down there are two sets A and B. A and B are two sets. Are two sets. Then A cross B. We read as A cross B. A cross B is going to be equal to, here we write ordered pair AB, and where A belongs to A. The first coordinate is belongs to the first coordinate A is a member of A, and this B belongs to B, and is called Cartesian product of two sets. So Cartesian product of two sets is going to be equal to A cross B, and A cross B equal to AB, where A is the element of A and B is the element of B. So you can see that here A. So if you wrote here A, then here in the first coordinate the element should be of A. Like here I can, if I'll write down here, suppose P cross R. So we consider P and R are two sets. Then here I have to write down this a small p, a small q, and here P belongs to capital P and a small q belongs to capital Q. Got it? Any doubt to understand what is called Cartesian product? And it will read as P cross R. Fine. Similarly, if you have, suppose we have n set a1, a2, a3, and so on an. So these are the sets. So how many sets? There are n sets. So here I can write down a1 cross a2 cross a3 and so on cross an. And here what we need to write down? The member of a1. Okay, so a. And the member of a2. So I can write down a2. And the member of a3 and so on an. And here I have to write down a1 which belongs to a1, a2 which belongs to a2, and so on, an belongs to an. Okay, these are the Cartesian product of n n sets. Okay, now so we learn how, what is called Cartesian product, and we learn first, we'll take consider two example. Here there are two sets A and B, and like here P and Q, P are another sets. So its element is going to be equal to, like, P is element of P and Q is the element of R, right? So P belongs to, oh sorry, here I should write down R, not Q. Okay, so P is the element of P and Q is the element of R. Here A belongs to A and B belongs to B. Similarly, like here I'll write down A equal to 1 2 and B equal to 3 4, and I would like to define A cross B. So what I'll do, I would like to define A cross B. So here we know that I have to take the element of A first. So here 1, and here we have to write down element of B. So what is the element of B? 3. Similarly, I can write down 1, and here I consider 3. We are writing in a set form, so element cannot be repeat, right? So here we have to write down 1 4, and now 2 3 and 2 4. Okay, so this is A cross B. Suppose I would like to write down B cross A, then what I have to write down? So here 3 and 1, 3 2, means first 3 and then 2, and 4 with 1 and 4 with 2. Fine. So here I have to write down 3 1 3 2 4 1 and 4 2. These are the way to find out cross product of two sets. Any doubt? Now I am going to define a relation. What is called a relation? So to define relation, what is called relation? So basically, if R is a relation from set A to set B, and if AB belongs to R, okay, then we write A is related to B. देखो ऐसे लिखना, A is related to B. Okay, if R is a relation from set A to set B, and if AB belongs to R, then we write A is related to B, and say that means say that A is related to B. Okay, now, and if A is not related to B, then we write A is not, like A is not related to B, then we have to write like this, A R then cross. Okay, and we say that A is not related to B. Fine. So here, like I'm going to define a relation. So here suppose R1. Okay, here what I'll do, I have to consider two sets. Okay, so I'll say this is the A, and A is going to be equal to A, take means let me take another A. So here I consider a set, okay, like if this is the set, and in this set what we have, b1, b2 and b3, these are the people, okay. And here I say b, let me write down a only, and b, s1, s2, s3, okay, these are the sets. And also here we have s1 also, okay. So but b1, b2, b3 and s1, s2, s3. Now I'm going to define the relation. So what I'll do, say R1, this is the relation. You can see that if R is a relation from A to B, and whenever we are talking about the relation R, then this R we can see here it has a element which is in order pair, right? AB, and it must have this R1 is going to be subset of A cross B. Okay, so suppose here means it is going to be subset of AB, like here A and B. So A is b1, b2, b3, these are the element of the set A, and s1, s2, s3 is the element of set B. Now I am going to define a relation. So in here I would like to write down as r1 ab, because देखो एलिमेंट जो r का होगा वो ऑर्डर पेयर में होगा, ab के फॉर्म में होगा. So that's why I write down here ab. And now here is belongs to A cross B. ठीक है, it means it is AB belongs to A cross B such that A is brother of B. यह एक तरह का रिलेशन है. तो अब यहाँ पे जो B1, B2, B3 है, बेसिकली हम यहाँ पे ना B1 लिखे, हम A लिखे. ठीक है, A क्या है, A is the going to be the element of A, दिस कैपिटल ए. और A इक्वल टू क्या हो सकता है, B1 हो सकता है, B2 हो सकता है, यहाँ पे मान के चलो S5 हो सकता है. दीज आर द पीपल. और यहाँ पे कैसे हम रिलेशन डिफाइन किए, ए इज ब्रदर ऑफ बी. ओके, नाउ I would like to define another relation R2. So here R2, I can say that AB belongs to A cross B such that A is sister of B. Okay, and I can also define like take another set R3, and here AB belongs to A cross B, and I can write down age of A is greater than age of B. ओके, अब देखो इसका मतलब क्या हुआ, यहाँ पे ए बी है. ओके, दीज आर हियर इन ऑर्डर पेयर वी हैव ए एंड बी and belongs to A cross B, and here I wrote down A is a brother of. Okay Rajesh, I am going to explain it again. देखो, relation, if R is a relation from set A to set B, and if AB belongs to R, then we write A is related to B and say that A is related to B. Okay, if it is true, then we say. If A is not related to B, then we say that A is not related to B. Okay, now basically this R is subset of A cross B. Okay, here you can see that I'm going to define on A and B. Okay, it is a subset. R is basically subset of A cross B. Now, so here I consider some example. There are some sets A, B1, B2. Its element is B1, B2, B3. Yeah, anything. Okay, that's why I wrote dot dot. Okay, it may be here 1, 2, 3. Okay, anything. So here A cross B. Suppose in this set it is going to be, but here I don't have to write down. Like here in this set B1, B2, B3, it is representing, and it like 1, 2, 3 is denoting its age. Fine. Now here you can see that A cross B, A is a brother of B, means here we have to consider, like we have to consider only those relation, those element which are brother of, means if A should be brother of B. Okay, so like here I'll say B1 and S1, means why we are considering these two element, since B1 is a brother of S1, that's why. Okay, means in which kind of element we have to take it. Now I'll take here AB and belongs to A cross B. Age of A is greater than age of B. Okay, like here we have to consider two elements. Suppose, and let me take A equal to 4, 5, 6, 7. Okay, age of A is greater than age of B. and B is going to be equal to 1, 2, yeah, 5, yeah, 9. Okay, so here what we need to do, we have to consider only those element, means we suppose I'll consider 4. So क्या है condition यहाँ पे, age of A is greater than age of B. अब देखो, age of A is greater than age of B, तो यहाँ पे 4 के साथ क्या आ सकता है, 1 आ सकता है, 4 के साथ क्या आ सकता है, 2 आ सकता है, क्योंकि 2 का एज क्या है, A से बड़ा है, it is greater, right? If I can consider 4 here, okay, and like here if you consider 4, I cannot write 5, क्योंकि 5 जो है क्या है, इसके एज से 5 means age of B is 5 and age of A is 4, which is not greater, that's why we cannot take. But you can see 5 1 we can take, 5 2 we can take, right? And also 6 1 we can take, 6 2 we can take, and 7 1 7 2 and 7 5. So these are the element of this R3. Got it? Now till here any doubt? Please reply. यहाँ तक समझने में किसी को कोई प्रॉब्लम? Okay, let me move ahead. So here A cross A. Okay, Neetu. 6 and 5. Yes, means there are so many elements, so I'm not going to write all. Yes, Saurabh, you are correct. So here, like every subset of A cross A is said to be a relation on A. Okay, so like here we have two element, means there is set A, and we are going to define A cross A, means okay, so this is going to be said to be relation on A. Okay, so it is a relation of it is a relation, sorry, every subset, sorry, every subset of A cross A, let me write down, every subset of A cross A is said to be a relation on A. So इस तरह का क्वेश्चन एग्जाम में पूछा जाता है, सच क्वेश्चन में भी आस्क इन द एग्जाम, 5 ऑप्शन दे देगा और उसमें जो है दे विल आस्क वेदर इट इज ट्रू या नॉट. ओके, नाउ नेक्स्ट पॉइंट, if suppose n A equal to m and B equal to n, there are two sets, then n cross A is going to be equal to m into n. अभी जैसे हमने डिफाइन किया था ना m into n, यहाँ पे देखो, यहाँ पे डिफाइन किया था A क्रॉस B. सो A में कितना एलिमेंट है, देयर आर नंबर ऑफ एलिमेंट इज 2, हियर नंबर ऑफ एलिमेंट ऑफ B is 3, sorry 2 here, and n of A is number of element is, so you can see that A cross B, so number of element in A cross B should be equal to 2 into 2, which is equal to 4. You can see 1 2 3 4, there are 4 elements. Similarly, so here I wrote, if n of A equal to m, n of B equal to n, then n of A cross B is equal to m into n. It's number of elements. Now if I'll talk about total number of relation, total number of relation, तो क्या होगा, कैन यू गैस? देखो टोटल नंबर ऑफ रिलेशन में क्या होता है कि वी आर कंसिडरिंग all the subsets, right? All the subset of A cross B. So all the subset of A cross B is going to be equal to what? अब देखो number of element of A cross B is going to be equal to n into m, and we know that if you have a set A and then its subset is going to be equal to 2 to the power n, right? So yes, 2 to the power mn is going to be the relation from B. Total number of relation from A to B is going to be equal to 2 to the power m into n. Fine. So these are the some formula. Now I am going to move. Any doubt? No. So here, let me write down here. So here what we have, let R be a relation. Okay, let R be a relation from A to B. Okay, so if R is a relation from A to B, then it is obvious that R is going to be subset of A cross B. It may be content. No. अब देखो जैसे हमने A और B यहाँ पे लिखा था, The A I say it is a first coordinate, B I say it is a second coordinate. But if I'll take all its element, इसमें जितने भी element आएंगे, suppose I am going to write down A such that A belongs to A and AB is related, AB belongs to R. Okay, for some B belongs to B. So here what I'm basically doing, so I'm considering all the, if R is a relation, okay, so R equal to AB. So what I'm doing, I'm taking only all the element, right, in general. So that's why I'm writing here. So A belongs to A and AB belongs to R, for some B belongs to B. Okay, so क्योंकि यहाँ पे सम इसीलिए लिखे कि because because like here if I'll write down, we are going to tell it is going to subset, right? So that's why I have to write down here sum, because there is a possibility that odds we cannot consider all the elements of B. Means like here what I mean to say, suppose 1 2, there are set 1 2 and 3. Similarly here you can see that I consider here in this example 4 5 6 7. So you can see that 9 is not coming now, 9 is not coming here. Okay, but all its element is coming. So that's why I wrote here for some B. So here A such that A belongs to A, AB belongs to R, means we are considering all its element, right? So that's why this A is called, means collection of this set is called domain of R. Okay, domain of the relation R. Now, if I'll talk about range of R, is going to be equal to B such that B belongs to B and AB belongs to R. And for some A belongs to A. Okay. No. So these are the definition. You should know it. Okay. Now let me go to any doubt. So these are the some property we should know it. अब देखो basically क्या है, A B suppose it belongs to R, then if you collect all its element, okay, like here, then it is going to be domain. And okay, if you collect all its element then of B like this, so we say a range. And then AB must belongs to her, and these are the collection, right, collection of all the points. Now we are going to learn some property identity relation. When I'll solve some question, it's like you will not face any, you don't have any, you will not get any doubt. Okay, so now I'm going to solve some problem after some time. So here I'm going to learn identity relation. So R is an identity relation if AB belongs to R. Fine. If and only if A equal to B, means A belongs to A and B belongs to B. What does it mean? R is an identity relation if AB belongs to R, if and only if A equal to B. That is A belongs to A and B belongs to B. Means every element of A should be related to only itself. Like if I define R, like here I say 1 1, 2 2, okay, 3 3. So these are the going to be the identity relation. Like 1 is related to 1, 2 is related to 2, 3 is related to 3. Got it? So these are the identity relation. Now they will ask you, yes, in the exam they are asking, like they will give you some condition and they will ask whether it is identity relation, yeah, not. Okay. Now after that I'm going to learn what is called reflexive relation. अब देखो यहाँ से ना प्रॉब्लम स्टार्ट होता है. A relation R on a set A is said to be reflexive if A is related to A for all A belongs to A. Means if A belongs to R for all A belongs to R. So a relation on a set A is said to be reflexive if number A is related to itself. Okay, suppose I am going to take a 1 2 3. Okay, this is the set. So what is the definition? A relation R on a set A is said to be reflexive if A is related to A for all A belongs to R. So A equal to 1 2 3. Okay, I consider this set. Now I am going to define a relation. So R1 is going to be equal to say 1 1 2 2. Okay, and 3 3. So here you can see that it means that 1 is related to 1, 2 is related to 2, and 3 is related to 3. So this is going to be the reflexive relation. Now I am considering another relation. So these basically you can see that R1 is a subset of A cross A. Okay, now R2. So here 1 1, 2 2, and 3 3, and 1 2, and 2 1, and 1 3. Can you tell me whether it is going to be a reflexive relation or not? Any guess? Can you solve it? So we have R2 equal to 1 1 2 2 3 3 and 1 2 2 1 1 3, and I'm asking whether it is going to be a no. Listen, so what is the definition? Saurav, you can see the definition of reflexive relation is a relation R on a set A is said to be reflexive if A is related to A. अब इसमें क्या देखना है? अब देखो 1 है 2 है 3 है. 1 is related to 1 2 2 is related to 3 3 is related to 3. Yes, we don't care about any other things. हमें जो कंडीशन है वो सेटिस्फाई कर रहा है कि नहीं करना. If it is yes, then it is going to be a reflexive relation. So it is a reflexive relation. Got it? Now I'll give you another relation. So R3. So 1 1 2 2 2 3 and 3 2. Now can you tell me whether it is going to be reflexive or not? Look at its definition. Can you tell me? This relation is going to be reflexive or not? Yes, Tanya, it is not. Yes, Saurabh, it is not. Why? You can see that in A we have 1, 2, 3, but here 1, 1, okay, 2, 2, yes, but there should be 3, 3. But in this relation, 3 is not related to 3. That's why it is not reflexive. Fine, good. After that, we are going to learn symmetric relation. So what is called symmetric relation? So here, पहले वाला identity. Yes, it is going to be, every reflexive relation is going to be identity relation. So symmetric relation. So a relation R on a set A is said to be symmetric relation if A is related to B, implies B is related to A for all A B belongs to R. अब देखो कंडीशन क्या कह रहा है कि that is if A B is related to a relation R, it implies that B is also related to R for all A B belongs to A. Okay, so here I'll write down A equal to 1 2 3. I'll take this simple example and explain. Okay, so here R1 में क्या है? अब देखो it is going to be symmetric relation whether or not. So here what I'll do, I'll say 1. Okay, 1 is related to 2. It means 2 should be related to 1. Okay, so can you tell me whether this relation is going to be symmetric or not? देखो इसमें क्या देखना है, जैसे उसमें क्या देख रहे थे कि हर एक जो यहाँ पे 1 2 3 था. So what we are doing, so we are taking all its element. Okay, means a relation on a set A is said to be reflexive if A is related to A for all A belongs to her. But here you can see that a relation R on a set A is said to be symmetric relation if A is related to B. पहला condition क्या है? A is related to B implies B should be related to A or a all AB belongs to R. Agar A is not related to B, then we don't talk about the B is related to A. Okay, so here we can see one is related to 2. Yes, it should then B should also be related to, means one is related to 2. It implies that 2 is related to 1. So means 1 in order pair we have to write, देखो ये दोनों एलिमेंट कंटेंट है इसमें. Yes, so we don't talk about others because other elements are not here, so this is going to be symmetry. Okay, any doubt? Now let me give another example. Take R2 equal to 1 2 2 1, okay, and 1 3 and 3 1. So whether it is going to be symmetric or not, so we'll check. So 1 is related to 2, it means that 2 is related to 1, means if 1 2 is in R2, then 2 1 should be also in R2. Yes, it is there. Okay, now we'll check another element. अब देखो similarly अगर 2 1 है तो like if you consider this one, so we'll get this one. Okay, so we'll not check this element. Now 1 is related to 3. Yes, then 3 should be also related to 1. It means 1 3 is in R2, then 3 1 should be in R2. Okay, it is there, so it is symmetry. Now I'll take another set R3. R3 equal to 2 3 1 3 and 3 3. Now I'm going to ask you whether it is going to be or not. You can see 2 3, 2 is related to 3. It means that 2 is related to 3. It means that 3 should be related to, if 2 3 is in R2, then 3 should be there also. It is not there, so it is not symmetric. We don't check about another element. Now you can see 1 3 is related to R. 3 1 should be also related to R, but it is not there. Okay, so if you consider any element, means here it should not be there. 3 3 belongs to R. Okay, yes, 3 3 belongs to R. Although it is satisfying this condition, but it is not satisfying. That's why it is not symmetric. No. Then after that, transitivity. यहाँ तक कोई डाउट भी है किसी को? Any doubt till here? Please let me know. A relation R on a set A is said to be transitive relation if A is related to B and B is related to C, implies A is related to C. अब देखो, for all A, B and C belongs to A. Now, what I'm saying is that if A, B belongs to R and B and C belongs to R, look at here. If this and this here A, it is important. If AB belongs to R and BC belongs to R, it implies that AC should be belongs to R. देखो A, B and C. ये क्या कह रहा है? A B से related है, B C से related है, then A must be related to C. It is called transitivity. Now take an example 1, 2 and 3. Fine. So here R1 is going to be equal to 1 2 2 3 1 3 and 3 2. So whether it is going to be transitive or not, तो क्या करेंगे? We'll check it. So 1 is related to 2 and 2 is related to 3. Here I'll take two pairs. Okay, 1 is related to 2, 2 is related to 3. Yes, then 3 should be related to 1. देखो 1 2 2 3 and 3 1. So 1 2 3 1 is not there. It is not transitive. Oh, sorry. I did mistake. So here 1 should be related to 2, 2 should be related to 3, then 1 should be related to 3. Okay, so yeah, so 1 2 2 3 and 1 3 is there. Now Now what I'll do, I'll take these two. So 2 is related to 3, okay, and then 3 is related to 2, yes, here. Then it means that 2 should be related to 2, but it is not there, right? It is not there, so it is not transitive. You got it? Now I'll take another example, R2. R2 is going to be equal to 2, 3 and 3, 1. So you can see that 2, 3 is related to R2, fine. Then let me write down in this way. So 2 is related to 3, 3 is related to 1. It means that 2 must be related to 1. Okay, so 2, 3 is in R2 belongs to R2, yes. 3, 1 is belongs to R2, yes. But 2, 1 is not belongs to R2. That's why it is not a transitive relation. Okay, no. I'll take another relation R3, 1, 3, 3, 2, and 1, 2. Fine. Now 1, 3, 3, 2, 1, 2. So here you can see that 1 is related to 3, yes. 3 is related to 2, yes. Then 1 should be related to 2. So it belongs to, means here I can say that 1, 3 is related to R, belongs to R3, 3, 2 is belongs to R3, and here 1, 2 is also belongs to R3. So this is transitive relation. So reflexive, symmetric, and transitive relation. You understood? Now I'll give you one question. So here the relation less than, yeah, equal to, and oh sorry, on the set of real number, on the set of real numbers, R is reflexive, symmetric, and transitive. Okay, reflexive, symmetric, transitive, reflexive, symmetric, and transitive. Okay, question mark. So you have to tell whether the relation on the set means like less than or equal to, we have a relation less than or equal to, it is going to be reflexive, symmetric, yeah, transitive. You can you tell me? I'll give you once 30 second. So in 30 second you have to tell me whether this relation is going to be a reflexive, symmetric, yeah, transitive. Any? Please reply. Like here what we need to do, basically I'm going to define the set on of real number. So here we have R, so R cross R, right? So I'll let me write on like this R. So this is the relation, right? R is a subset of R, and here what I'm going to A and B such that A is less than equal to B. So you have to tell whether this relation is going to be reflexive, symmetric, or transitive. Yes, yes, Saurabh, it is going to be a reflexive. What about symmetric and transitivity? Transitivity? प्लीज रिप्लाई इन द चैट बॉक्स. और किसी को प्रॉब्लम है या समझ नहीं आ रहा है, प्लीज लेट मी नो. Okay, so here you can see that what I'll do. So for reflexive I'll check for reflexive, and so in reflexive, so what we need to do, so a should be belongs to R, means A should be related to A. सिमेट्री भी होगा लग रहा है, लगना नहीं चाहिए, आप एग्जैक्टली बताइए. So you can see that A belongs to R. अब कंडीशन क्या है? A is related to A means A should be less than equal to A, and it is true. अब जैसे देखो 2 is less than equal to 2, 2 is less than equal to 2, it is true. Why? क्योंकि जब हम इनइक्वालिटी साइन देते हैं तो एक कोई ना एक कंडीशन ट्रू होना चाहिए. 2 is less than 2 रहता है तो इट इज रॉन्ग. बट यहाँ पे क्या है, it is, this is true, so 2 equal to 2, कोई एक true हो रहा है ना, that's why this, it is going to satisfy. So if you take any real number, so it is going to satisfy. Okay, you can take minus 2 is less than equal to minus 2, yes, since minus 2 equal to minus 2. Okay, so it is going to be reflexive. Now symmetric. So for symmetric, we need to do like here, a, if AB belongs to R, AB belongs to R, okay, if AB belongs to R, implies that BA should be belongs to R. Means if A is less than B equal to B, it implies that B should be less than equal to A. अब देखो, take simple example. 1 is less than equal to 2. Does it imply that 2 is less than equal to 1? It is wrong, right? So it is not symmetric. Now talk about transitivity. So in transitive relation, so what we have, if AB belongs to R and BC belongs to R, then it must AC belongs to R. अब देखो, A belongs to B, like take 1 is less than equal to 2 and 2 is less than equal to 3, it implies that 1 is less than equal to 3. Yes, so take any real number. Okay, so if A is less than equal to B and B is less than equal to C, then it implies that A is less than equal to C, and for all A, B and C belongs to a real number, so it is transitivity. So it is a transitivity, means it is specifying the transitivity condition, but not symmetric, but it is also reflexive. So this relation on less than equal to is a reflexive relation. It is a transitive relation but not symmetric relation. आया सबको एक क्वेश्चन समझ में? Any doubt? Okay. Now, so there are some more question. Now, if empty relation, I would like, I forget you, empty relation. Like if you have A cross B, okay, like A cross B, there is a relation. If R equal to, simply I'll write down R equal to 5. Okay, there is no element, it is called empty relation. So I'll give you an example. Let A equal to set of all students of a boys college, okay, yeah, boys school. Now I'm going to establish a relation. So here what I'm doing, the R equal to A and B, okay, such that A is sister of B, where AB belongs to A. You can see that means all the student who are in means all the student, this is boys school, right? So all student has to be boys, but here what I'm writing, so AB, these, I'm saying that these A and B are the element of A, but the condition is A should be sister of B, which is wrong, since A B has to be boys. Okay, if A and B are boys, it cannot be sister. Means if like both are boys, so we cannot establish a sister relation here, right? So this is not going to be, means all the it doesn't contain any element, so this relation has to be empty. Okay, now so here if a relation, equivalence relation, so if a relation, like I can write down a relation R on a set A, let me write down a relation R on a set A is said to be an equivalence relation on A when R is number 1. It should be reflexive, it should be symmetric, and it should be transitive. Okay, so like if a relation okay, so you can see the equal relation, equality. Okay, if you consider a real number, so if you consider equal relation, okay, so it is going to be what? It is going to be a equivalence relation. You can see that means a should be equal to a, means if a is related to what is the relation? Equality. Okay, means a should be equal to a is related to a, since a equal to a, right? So it is reflexive for any real number. Okay, it is going to satisfy. Now if I'll say a is related to b and b is related to a, then it implies that, you can see, means if a, oh sorry, so here a and b belongs to r, oh sorry, a is related to b, it implies that b should be related to, you can see that a equal to b, it's obviously b equal to a. If both elements are equal, then it b should be equal to a, like 2 equal to 2. You cannot write 2 here, b is a representation only, it is a variable. Okay, so 2 equal to 2, it implies that 2 equal to 2, both are element, means if a equal to b, then b should be equal to a. Similarly, A is related to B and B is related to C. It implies that A is related to C. अब equal relation है यहाँ. So A equal to B and B equal to C. Obviously, it implies that A equal to C. Okay, so you can see that equality relation is equivalence relation. Okay, now. So you should know these are the basic concept of relation. In your exam, I don't think they will ask. Okay, so I'll share some question with you, and you just need to solve it. Only this is enough theory about the relation. Fine. Now I am going to teach you what is called function. So before moving to function, so in relation, let me ask. In relation, do you have any doubt to understand what is, how to find out whether it is going to be equivalence, yeah, reflexive, symmetric, identity, transitivity? Any doubt? Please reply in the chat box. किसी को कोई भी डाउट है? Please reply in the chat box. No doubt? Should I move ahead then? Hello? Okay, Saurabh. Okay, Tanya. No. So, good, good. So here, what I'm going to do, teach you. First of all, I'll tell you what is called dependent variable and independent variable. Okay, dependent variable. So I am going from basic. Okay, independent variable. So here I'll define what is called dependent variable and independent variable. So let me write down the definition first and then I'll explain it. So the variable whose value is assigned is called the independent variable. I'm writing in short. And the variable whose value is often corresponding to assigned variable is called dependent variable. So here what I'm going to tell you, look at here, the variable whose value is assigned is called independent variable, and the variable whose value is often corresponding to assigned variable is called dependent variable. Let me take a simple example. Okay, so here, you know, the area of circle is going to be equal to pi r square, right? So here you can see that if you assign the variable of r, value of r, suppose r equal to 1, r equal to 2, r equal to 3, like here this is the this and this, what you can see that radius is going to change, right? So if radius is going to vary, our area is going to be vary, right? So the area is dependent upon radius. That's why here I wrote the variable whose value is assigned is called the independent variable. So here we are going to assign the value of what? We are not going to assign the value of area. We are going to assign the value of radius, right? So that's why radius is independent variable here. And the variable whose value is obtained corresponding to assigned variable is called dependent variable. Means that this area is dependent variable and the radius is independent variable. Understood? Okay. So we have lots of example you can take. This is the simple example, so you can understand understand the concept of dependent variable and independent variable. Now I am going to teach you one of the important concept, function. So you understood what is called function. Okay. So consider A and B are two non-empty set. Consider A and B are two non-empty set. Two non-empty set. Okay. Okay. So before going to teach you function, I would like to explain some interval. What is called interval? I think that would be sorry. So here interval. So you know that you have this is the number line, right? This is the number line. So here 0 and here 1, 2, 3. Basically, this is the I have to write down properly. So this is the 1, 2, 3, and 4, and so on. Here -1, -2. These are the integer. So you can see that if I can find out lots of numbers between 0 and 1. Okay. So if I can draw any point dot here, so these are the number on number line. So basically I draw here and I can draw here, so it is going to be a it is this line is a real number. Okay, means on every real number you can draw here. Okay. Now, so interval we in like here we will say a is equal to a is less than equal to b. Okay. So now we are going to define some interval. So in interval in the form of say. Okay. So here what I am going to open interval. What does it mean by open interval? Like here a and b, we write down open interval as ab. And what does it mean? That x such that a is less than x less than b. Okay. What does it mean? That here we have a number line a and b. Okay. On number line I wrote 1 and like a and b. Okay. So here we have open interval. So in open interval what we need to do, we don't have to consider these 2 points. Means all the points between 1 a and b, but we don't have to consider a and b. Okay. So like here I write down 2 3. 2 3 means here 2 and 3. So it means that this is open interval. That's why we don't have to include 2 and 3. We have to exclude 2 and 3, and all the points remaining means I can write down in the set x such that 2 is less than x less than 3. Okay. All the element we have to consider between 2 and 3 now. So this is called open interval. If I say close interval, in close interval what we do, in close interval what we do, so this is a number line. Okay. So here I write down in square bracket we have to write down, and it means that x such that x is less than, oh sorry, a is less than equal to x less than equal to b. Means all the element which are between a and b, and also we have to include a and b. Okay. That's why equal sign. And then we have half open intervals. Okay. So half open intervals. Half open interval means like here there are two types. So here AB. Okay. And I can write down AB. So it means that like on number line we have to include A, but we have to exclude B. Okay. Now here A and here B. It means that we have to exclude A, but you have to include, oh sorry, b, we have to exclude a, we have to exclude b. We can write as like here we can write as x such that a is less than x less than equal to b, and we can write down as it as x such that a is less than x and less than equal to b. Oh sorry, here I have to write down a less than equal to x less than b. Okay, so I think you understood this interval. Okay, now when we'll do application of this interval, we'll understood what does mean. So this is the basic concept about the intervals. Now I'm going to tell you what is called function. So we learn what is called dependent variable, independent variable. Now I'm going to teach you function. Okay, so in a function what we do, so consider a and b. Okay, consider a and b are non-empty set. Fine. And f mapping a to b. So f mapping a to b, for all x belongs to a, there exists unique y belongs to b such that f of x equal to y. अब देखो इस डेफिनेशन को समझना है अच्छे से, एंड इट इज वेरी इंपॉर्टेंट. मैंने क्या लिखा है, कंसीडर ए एंड बी. सो वी आर कंसीडरिंग टू सेट्स. तो बेसिकली यहाँ पे जो सेट हम लिखते हैं ए एंड बी, ये इस इंटरवल में लिखते हैं. ओके, अब जैसे देखो यहाँ पे लिखेंगे एफ मैपिंग ए टू बी. ओके, मैपिंग बी टू ए. जैसे लिखेंगे एफ मैपिंग 2 to 3 and 3 to 2 या 2 to 3. Okay, yeah, we can write on f mapping a to b, yeah, like 0 to 1 and here 0 to 1. Yeah, here I can write f mapping 2 to 4 and oh sorry, f mapping 2 to 4 and 4 to 16. Got it? So यहाँ पे मैं क्या लिखा हूँ, so that's why I introduced about the what is called interval. Now consider a and b are non-empty set and f mapping a to b. For all x belongs to a, there exists unique y belongs to b such that f of x equal to y. क्या कह रहा है कि consider a and b. ओके, नॉन एम्पिटी सबसेट एफ मैपिंग. देखो सेट क्या होना चाहिए, नॉन एम्पिटी होना चाहिए. मींस ए शुड नॉट बी इक्वल टू एम्पिटी. कोई भी सेट क्या होना चाहिए, एम्पिटी नहीं होना चाहिए. बोथ आर शुड बी नॉन एम्पिटी. पहला कंडीशन क्या है, ए शुड नॉट बी इक्वल टू 5 एंड बी शुड नॉट बी इक्वल टू 5. उसके बाद क्या करें, मैं कह रहा हूँ एफ मैपिंग ए टू बी. एफ मैपिंग फंक्शन को कैसे पढ़ेंगे, एफ मैपिंग ए टू बी. उसके बाद क्या लिख रहा हूं मैं, फॉर ऑल एक्स बिलोंग्स टू ए, यानी कि ए में जितना भी एलिमेंट होगा. ओके, फॉर ऑल एक्स बिलोंग्स टू ए, देयर एग्जिस्ट यूनिक वाई बिलोंग्स टू बी. बस इसके करस्पॉन्डिंग जो भी वैल्यू आएगा वो क्या आएगा, यूनिक आएगा. अब एग्जांपल लेते हैं. एफ ऑफ एक्स इक्वल टू, मान के चलो एक्स स्क्वायर एक फंक्शन डिफाइन किए. ओके, एफ मैपिंग हम अभी सेट ले रहे हैं 1 2 3. ओके, एंड हियर 1 4 and 9. You can see that f of 1, अब जैसे f of 1 लिखे तो 1 जहाँ पे x था वहाँ 1 पे रिप्लेस करेंगे. सो 1. अब f of 2 लिख रहे हैं तो 2 यहाँ पे f of x इक्वल टू एक्स स्क्वायर. अब f of 2 लिखेंगे तो 2 स्क्वायर लिखना होगा विच इज इक्वल टू 4. तो देखो 4 है यहाँ पे, यानी कि बेसिकली यहाँ पे क्या कर रहा है 1 2 3 और यहाँ पे क्या कह रहा है 1 4 9. एंड f of 3 विच इज इक्वल टू 3 स्क्वायर विच इज इक्वल टू 9. सो 1 1 पे मैप हो रहा है, 2 4 पे मैप हो रहा है, 3 9 पे मैप हो रहा है. फाइन. अब देखो तो यहाँ पे यूनिक आ रहा है ना, यूनिक, इट इज गोइंग टू बी यूनिक. नाउ आई एम गोइंग, दिस इज द सेट 1 2 3. ओके, दिस इज अनदर सेट. आई एम गोइंग टू डिफाइन सम एनी फंक्शन, सपोज 5 6 7. अगर 1 5 पे आ रहा है, 2 भी 5 पे आ रहा है. ओके, एंड 3 6 पे जा रहा है. लाइक हियर यू कैन टेक example -1 1. Okay, f of x equal to x square. So it is going to be f of -1 equal to 1, f of 1 equal to 1. So -1 and 1, even though it is going to be function, but here what we have, f of 1 equal to 5. I consider any other function. Okay, there is a f, this is not this f. Okay, f of 1 equal to 5 and f of 2 equal to 5, but here 3 is going to be 7, f of 3 equal to 6 and f of 3 equal to 7. You can see that here 3, it is mapping to 2 value, so it is not going to be function. अगर कोई भी फंक्शन है तो क्या होना चाहिए, पहला तो यूनिक इनपुट होना चाहिए, आउटपुट होना चाहिए, ठीक, इसका इस पे मैप होना चाहिए, और दूसरा क्या, इट शुड बी यूनिक. Okay, like here we'll take circle, here f of x equal to x square, x square. Yeah, how can I can consider? So usually we no, suppose f of x equal to x square. अब देखो f mapping minus infinity to plus infinity. So here I have to write down minus infinity to plus. इसका मतलब क्या है, ये जो रियल लाइन है तो ये we take consider all the elements, all positive and all negative, and mapping to यहाँ पे क्या कर रहे हैं हम, देखो जीरो पे ओपन है और इन्फिनिटी, और यहाँ पे क्या है कि जीरो इज एक्सक्लूडेड एंड टिल इन्फिनिटी. अब देखो, अब कोई भी एलिमेंट ली, एफ ऑफ एक्स इक्वल टू एक्स स्क्वायर, एफ ऑफ 1, एफ ऑफ -1, f of -1 equal to 1, f of 2 equal to 4, f of 3 equal to 9, and here 0 is there, f of 0 equal to 0. but देखो अब ये 0 इसमें है, 0 doesn't belong to 0 to infinity. अब मैंने डिफिनेशन में क्या लिखा है, माइनस, मतलब कि इट शुड बी यूनिक. ओके, देयर एग्जिस्ट, पहले क्या लिखा है डिफिनेशन, देयर एग्जिस्ट, देयर एग्जिस्ट, एग्जिस्ट तो होना चाहिए, एंड इट शुड बी आल्सो यूनिक सच दैट f of x इक्वल टू y. यहाँ पे देखो हमने क्या किया, ये तो लिया, जीरो वाज हियर, जीरो इज हियर, राइट, बट जीरो डजंट बिलोंग टू दिस. यहाँ पे क्या कह रहा है, यहाँ पे एग्जिस्ट ही नहीं हो रहा है, यूनिकनेस की तो बात ही नहीं, यहाँ पे एग्जिस्ट नहीं हो रहा. सो f of x इक्वल टू x स्क्वायर इज नॉट अ फंक्शन. ओके, नॉट अ फंक्शन when f mapping minus infinity to infinity to 0 to infinity. ठीक है, बट देखो it is going to be function when you consider f of x equal to x square is a function. yes, only one output होना चाहिए. is a function is a function when f mapping minus infinity to infinity and map to close interval 0 to infinity. ओके, तो इसमें क्या होगा, ये फंक्शन होगा, बट यहाँ पे ओपन है, दैट्स व्हाई इट इज नॉट गोइंग टू बी फंक्शन बिकॉज जीरो इज नॉट हियर. अब कह रहा है कि इसका तो इनपुट होना चाहिए. अब जो सेट का हम कर रहे हैं, अब जैसे लाइक हियर आई विल टेक f of 1 equal f of x equal to x square, and this map is defining from 1 to, okay, and here I write down 1, okay, and 9. so here you can see that f of 1 equal to 1, f of 2 should be equal to 4, 1 is mapping to 1, but 4 is not here, 4 doesn't belong to 1 9, right, this set. Therefore this f of x equal to x square is not a function on this domain and range, means it's not a function on 1 2 to 1 9. got it? आया आप लोग को समझ में, कोई डाउट? so there are lots of thing about function, we'll talk it in the next class. अब तक कोई डाउट है, प्लीज लेट मी नो, और इन द नेक्स्ट क्लास विल डू सम प्रॉब्लम, जितना भी डाउट होगा वो क्लियर हो जाएगा. एंड फॉर रिलेशन आई विल शेयर सम क्वेश्चन. ओके, ऑलमोस्ट ऑल क्वेश्चन विल बी लाइक कॉम्पिटिटिव टाइप जो एग्जाम में आ चुका है, आई विल शेयर. ओके, एंड आल्सो सम गुड क्वेश्चन, सब्जेक्टिव टाइप ऑफ क्वेश्चन. सो यहां तक समझने में किसी को भी कोई डाउट, please reply in the chat box and also give feedback. कोई डाउट है? Any doubt? Please reply in the chat box. Saurabh, Vivek, Tanya, any doubt? Deepak, any doubt? Megha, Aditya, any doubt? Okay. Okay. So good night. Take care. Okay then.